Almost any task we perform carries some risk of failure or injury. How do we determine we're performing a task in the safest way possible? With some jobs, it's a simple answer. We wear the proper protective equipment like a hard hat or a fall-arresting harness. Other tasks may require us to think about all predictable and potential hazards, meaning we have to expect the unexpected. Leaving a hazard unnoticed is one of the greatest threats to safety. Risk assessment is the foundation of the process to prevent accidents and ensure personal safety and the protection of property. In this program, we will learn what risk assessment is and the principles that drive the assessment process. Which risks need to be assessed, by whom, and how thorough should the process be. Commonly used tools and methods to identify hazards. We'll detail the assessment process, how risks are ranked, and how existing controls are identified. We'll show you the process of creating a risk acceptability and control action plan, and we'll see the actions to be taken once the risk assessment process is complete, along with the need for regular reviews. How do we define risk? Risk is the potential to lose something of value and includes everything from the equipment we use, the vessel we work on, to a human life. It can even be expressed mathematically, where risk equals the consequences of an accident multiplied by the number of times a task is performed, or the exposure factor, and the probability that an accident will occur during that task.
You multiply, and that gives you your exposure level, so it can give you that mathematical roadmap to evaluate the risk. Once you've done that, then you take all of those things when you've got exposure and you figure out what your mitigators are.
Risk assessment is the process where we identify hazards, see if they're likely to occur, and what the outcome will be if they do occur. Each element is assigned a value. The higher the value, the greater the chance of severe injury or loss of life or property, establishing an immediate need for corrective action. We can reduce risk by putting controls in place that lower accident probability, and in some cases will even reduce the severity of an accident if it occurs. Risk assessment procedures vary from task to task. They include evaluating unavoidable risks in order to lower the potential for serious injury or property damage, along with creating safeguards against all identifiable risks, as well as complying with international, flag, and port state regulations. The International Safety Management Code, or ISM, requires all employers to provide methods of risk identification along with establishing the safeguards to reduce risk, and have them readily available in the Safety Management System, or SMS. Periodic safety audits help ensure these procedures are working properly. How do we determine which risks we need to assess? Every task should be evaluated to determine the likelihood of injury or damage to property. The primary aim is to identify all hazards. When carrying out a risk assessment associated with a new task, all hazards with significant risk may require a team approach to identification.
I think it has to happen from the worker themselves all the way up to upper management, from both perspectives.
An initial assessment needs to be thorough. Subsequent assessments would review any new hazards associated with the task. Risk assessment is a continuous process. Companies are evaluating and re-evaluating hazards all the time. These assessments are then provided to supervisors or vessel masters to ensure all work has the proper assessment before anyone starts the task. For routine tasks, risk assessment can be done using simplified checklists. Critical and non-routine tasks require a more formal process. There are several tools commonly used to assess risk. As we saw earlier, risk can be expressed mathematically, and if we know the likelihood a given outcome will occur, a risk assessment matrix can be used to measure the potential effects of failure or injury based on the severity of the incident. The most commonly used matrix is the 5x5. On one side, the probability is ranked from least to most likely to occur, and on the other is the possible outcome, also ranked from negligible to severe consequences.
And you add those all up, and you come out with a matrix, and you can determine if it's a red, amber, or green situation depending on those totals.
A low number indicates minimal risk, while a high number means the results can be catastrophic should an accident actually occur. Identified hazards should be evaluated for their consequences, as in how severe could the loss be. Hazards with severe consequences, should something go wrong, lead to a high-risk ranking. These are considered to be significant risks and require more attention.
So if you engineer a solution and add training and additional protective equipment, then you're getting to a much lower level of risk.
How often a hazard occurs is referred to as the frequency. It also requires more attention for suitable control. Another widely used tool is the checklist. A checklist creates a workflow where we can make sure all the proper PPE, tools, supplies, and permissions are in place before work begins. Some checklists require a supervisor or senior officer to approve before a task starts. A permit to work for confined space entry has very specific requirements, as well as a chain of command involving several supervisors who have to approve the process before work commences. Other tools include guides, handbooks, questionnaires, and interactive programs that guide us through the risk assessment process. The risk assessment process begins when we ask the questions, what can happen and how bad could it be? That is to say, we're identifying possible hazards and the severity of harm that could result. For routine jobs with no significant hazard, following a checklist or briefing crew with an informal job safety conference or toolbox meeting will be sufficient to minimize an already lower risk. Documenting these procedures is also not necessary. For tasks with significant hazards, assessments should be reviewed to determine if any additional hazards exist.
Having a system in which you can record near misses can prevent injuries. And if you're tracking injuries, that's a good way to assess the next higher level of problems, which are, of course, fatalities.
Additional measures can be written into the process to ensure we take adequate steps to minimize risk. As we saw earlier, a risk matrix can be used. A flow chart can also help determine the steps required to adequately assess the risk for a given task. First, work is divided into groups such as navigation, cargo operations, deck operations, and engineering. Once the activity has been placed into a group, our next step is to identify all potential hazards. The following 3 questions: is there a source of harm? Who or what could be harmed? And how could harm occur? Are useful to identify hazards. Another reliable method is the structured what-if technique, or SWIFT. SWIFT also relies on questions to identify risk. It starts with, what if? As in, what if the generator fails, or what if a mooring line parts? What can go wrong? What if it occurs? What would be the consequences? Is there a source of harm or loss, such as people, property, or the environment? How could harm occur? How could? As in, how could any other possibilities occur? Is it possible? As in, is it possible for a generator, pump, or mooring line to fail? The SWIFT process is not limited to these questions. Once risks have been identified, then we need to determine what the depth of loss associated with a risk might be. These risks are divided into 4 categories: the risk to people, the risk to the environment, the risk to property, and the risk to business. The process of risk assessment does not end with a risk ranking. Determining if a risk is acceptable requires examining the controls already in place, as well as determining if any new controls need to be considered. Examples of existing controls include safety devices already in place, permits to work, port or flag state regulations, and the use of proper tools and equipment. Risk is considered acceptable if it has been reduced to a level that is as low as reasonably practicable, or ALARP.
You never want to accept the risk of killing somebody. You never want to accept the risk of knowingly going to hurt somebody. So the acceptable risk is a very low probability of somebody getting hurt.
The ALARP principle establishes the relationship between the economics of implementing controls and the acceptability of risk in a hazardous activity. Jobs with unacceptable risk should not be undertaken. In these cases, the risk assessment should be reviewed and further steps taken or additional controls added to reduce risk. If a particular risk reduction involves a prohibitively expensive process that results in little improvement, it can be considered not reasonably practicable. Tasks with negligible risk, as well as adequate controls in place, should still be subject to a review process to ensure that risk levels remain low. Once all risks have been identified, the next step is to decide what action should be taken to improve safety, taking into account all existing controls and precautions. In jobs with a very high risk, if that risk cannot be lowered even with unlimited resources, work should be prohibited. Risk assessment made at the initial stage for a task will remain the same for future operations and reviewed every time the task is undertaken again. Additional precautions may need to be taken due to weather or other factors. Those decisions would be made during a job hazard analysis meeting before the task is performed. The outcome of any risk assessment should be a list of actions ranked in order of priority. These are commonly referred to as the hierarchy of controls, with the first step being the most effective but more difficult to accomplish, and the final action being the least effective but easiest to implement. The proper controls are then chosen by taking the following considerations into account. Could using a better tool or system reduce or eliminate the risk? Can a less hazardous or risky control be used instead of a more common solution? Would enclosing the hazard or placing a worker inside an enclosure, such as a cage, offer further protection? Could a physical barrier to dangerous equipment, such as a guard or cover, be put in place? Can limiting the amount of people in a high-risk area provide an effective control? Will limiting the amount of time a worker spends in a high-risk area provide an additional barrier to injury? Will adequate supervision of tasks by an officer or maid provide additional protections? Would the posting of warning signs or instructions raise awareness? Use of personal protective equipment is an effective barrier to many risks and should always be considered. Making written procedures available in the company or ship's safety management system, in addition to regular reviews of procedures for changes in the risk assessment level, are also considered to be regular actions to be performed. In this program, we learned about the risk assessment and its underlying principles, which risks need to be assessed and why, the commonly used tools to determine risk, including the risk assessment matrix, the actual risk assessment process and how tasks are ranked based on degree of risk, how a risk acceptability and control action plan is created, and the actions that are typically created once the assessment process is complete.
So it's a constant process of evaluation, reevaluation, redevelopment, execution, and then look at it again.
Risk assessment is an important tool which can help safeguard against hazards, large and small. A systematic and measured approach to risk identification and the selection of appropriate controls helps to create an environment where we all can work safely together.